Imagine you launch a ball into the air. It rises, arcs, and lands. Now here's a fun question. What if the highest point it reaches is exactly the same as how far it travels? What launch angle makes that happen? Pause and think about it. Let's set up the physics. When a ball is launched at angle theta with speed v0, it follows a parabolic path. The maximum height h depends on the vertical component of velocity, and the range r depends on both components together. Let's write these down. Here's where it gets interesting. We want height to equal range, so let's set them equal. Notice that v0 squared over g appears on both sides, so it cancels completely. We're left with sine squared theta over 2 equals 2 sine theta cosine theta. Divide both sides by sine theta, and we get sine theta equals 4 cosine theta. Dividing sine by cosine gives us tangent, so tangent of theta equals 4, and theta is the arctangent of 4. Punch that into a calculator and you get roughly 76 degrees. That's surprisingly steep, much steeper than the 45 degrees most people guess. Let's see it in action. Watch the ball launch at 76 degrees. It rises steeply, and look, the peak height and the landing distance are exactly the same. The height equals the range, just as we proved. So the answer is arctangent of 4, roughly 76 degrees. Most people instinctively guess 45, but that only maximizes range. When you want height to match range, you need to throw much steeper. The key insight? Height goes as sine squared, but range goes as sine times cosine. Matching them forces tangent theta to be 4. Follow for more physics teasers like this.